Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GHG Cloud. And today we will be talking about why you should install a ground source heat pump. We talked already quite a lot on this YouTube channel on bore fields, bore field physics, etc. But of course, bore fields go together with a ground source heat pump. And nowadays there is quite a lot of competition from other renewable technologies, and most significantly from the air source heat pump. So let's discuss why a ground source heat pump might be a better idea for your individual or bigger project. Now, before we start, I want to discuss the elephant in the room, namely the capex, the capital expenses, the investment cost of ground source heat pump. Because it is typically true that a ground source heat pump, due to the fact that you also have to install the geothermal part, is more expensive from an investment point of view than air source heat pumps. Now I say mostly because it's not by definition the case. For example, and we will discuss about noise later, in some regions, densely populated areas, if you install air source heat pumps, you have to take into account certain measurements, certain measures in order to make sure that the noise level is below a certain threshold. And this extra investment cost sometimes compensates for the higher investment cost of geothermal systems. So it's not even the case that in all situations a ground source heat pump is more expensive, but typically for a residential project, a single house, it is. But if you then, for example, again move towards a collective system where you can actually share the investment cost of your geothermal source, it might as well not be the case. So that was just something I wanted to say about the investment costs. It's to keep in mind that it's most probably it is a more expensive technology and investment cost, but it's not by definition the case. And that's an important nuance that's sometimes missing in this debate. Now, that being said, let us talk a little bit about the advantages of ground source heat pump. Now, we will be talking about quite a lot of things, and I made a distinction between individual reasons, why you as a house owner, why you want for your individual reasons a ground source heat pump, and then collective reasons. So let's start with the individual ones. And the first one is efficiency. Now, ground source heat pumps have the name of being more efficient than air source heat pump. Now, is that so? Well, the efficiency of a heat pump is actually determined by the temperature difference between the source of the heat and the supplier temperature of the heat. So, the colder the temperature is you get your heat from, the lower your efficiency will be. So, since typically the ground temperatures during a heating season, during winter, is higher than the air temperature, yes, your ground source heat pump is more efficient than your air source heat pump. And this higher ground temperature is also because of something which is called seasonal thermal energy storage, namely that when you work with a geothermal system, you're not so much using the ground as a source, you're also storing heat into the ground. So in summer when you're cooling, you store this heat into the ground, whereby you raise the ground temperatures, and this higher ground temperature gives you a higher efficiency for your heat pump. And this is why typically the efficiency of a ground source heat pump is higher. Also, if you look at the official data, you look at technical documentation, typically your ground source heat pump has a higher efficiency, but what we see is that over the years, air source heat pumps are getting closer to the efficiency. And that's because, of course, thermodynamically, the refrigeration cycle and the compression cycle, it has the same efficiency. It's the same physics. So in theory, it should reach the same efficiency. The reason why it's not is because a ground source heat pump, it's circulating a fluid, and the fluid has to give away the heat to a refrigeration cycle, and that is a little bit easier than getting energy out of the air. So it's not so much the efficiency for the refrigeration cycle itself, it's more also related to the way the energy is given to the refrigeration cycle. But that being said, air source heat pumps are getting closer to the official data for the efficiency. Now, related to this official SCOP, the seasonal efficiency of the seasonal coefficient of performance, there is a danger in that, because it's typically written as B0W35 or W55, which means that if your ground is 0 degrees, then and you give away the heat at 35 or 55 degrees, then you have this efficiency. But this is typically an underestimation, and we discussed that before already. But if you design a ground source heat pump with your bore field correctly, you typically don't get these temperatures of 0 degrees. So you're typically higher, meaning that your efficiency is also higher. So that's a reason why you should pay attention, because the efficiency of your ground source heat pump is typically somewhat higher than your official efficiency. But also, and that's the other side, that due to climate change, regions that typically had colder winters in the Netherlands, Germany, Belgium, they are experiencing less and less extreme winters. So it's getting typically warmer outside. And this first point where the ground temperature is higher than the air temperature, it still holds, but less frequently, let's say, because the air is getting warmer. So the seasonal efficiency of your air source heat pump, and here in practice, is getting closer to, or even sometimes better than, the ground source heat pump. So some people say, well, the efficiency is now due to climate change in certain regions, it's better than the ground source heat pump. And yeah, that can be in some particular context, but that does not mean that the heat pump is cheaper to operate. Because there is a difference between efficiency and operational costs. Now, if you look at electricity prices, for example, some of you might still have fixed prices, but over time this will more move towards a dynamic electricity price with the price per hour, or even with a higher resolution. And this is because, well, due to renewables, we are not only consuming electricity, we're also producing electricity, and the whole market is changing more towards this dynamic behavior. And what we see is, when is this electricity price the highest? It's when there is a high demand and a low production. And then the prices are high. It's demand and supply. Now, when is this demand the highest and the production the lowest? Typically when it's winter, because it's cold outside and it's dark, so the solar panels do not work, and there is no wind, so the wind turbines do not work. And the supply drops and the demand increases because we want to heat our buildings. We want to light our buildings. So then the price is the highest. And at this point, we're rather sure that the air temperature is colder than the ground temperature, because we're now extremely wanting to heat our building. So we know that our ground source heat pump is here way cheaper than your air source heat pump. And it's only in the months of, or the seasons of autumn and of spring, that it's not sure when which efficiency is better. It really depends on your climate, but when you take into account this variable electricity price, you're almost guaranteed to have a lower operational cost than with a ground source heat pump, due to the fact that it's way more efficient at times that it actually matters. Next to that, air source heat pump also experience something which is called the defrosting cycle. Now, an air source heat pump, it takes the energy out of the air. There is moisture in the air, and it can be that if it's cold outside and you extract the energy from the air, it cools down, and that the moisture actually freezes. It freezes on your heat exchanger, and when there is ice there, it cannot function anymore. So that's why there is a defrosting cycle with these type of systems. But these defrosting cycles, they require electricity. So what they need to do is instead of cooling down the air, they need to heat up the heat exchanger to melt the moisture, to let it evaporate, because this defrosting cycle, typically the heat pump looks like it's on fire, but it's just evaporating the water. So that means that when it's doing that, it stops heating your building. And if you have a big building, you typically have to have multiple of these machines working together in order to make sure that your building demand is actually met, while some of the other machines are defrosting. But it also consumes electricity because you're literally evaporating or melting water, which is not used to heat your building. So that's why, especially in very cold climates, the efficiencies of these air source heat pumps are in practice also way lower than ground source heat pump, because this defrosting cycle consumes electricity. Now, on the other side of the spectrum, instead of talking about heating in the defrosting cycle, we also have very effective cooling with ground source heat pumps. And I also, and again, want to focus on the seasonal efficiency, the seasonal thermal energy storage. Because in winter, we're cooling down the ground, so we're loading the ground with cold. And this cold can be used in summer for passive cooling. So we don't need the heat pump when we're passive cooling. We can just use the colder ground temperatures of 8 to 14 degrees, let's say, to cool your building. Now, in really warm climates, Spain, Italy, Australia, you can also use active cooling. And we talked about the combination of active and passive cooling in the past for commercial buildings and offices. But when you're active cooling, we again have the same story as before. So your ground source heat pump is more efficient than your air source heat pump, because your ground temperature will be lower than your air temperature. In these warm Mediterranean climates, when it's 40 degrees outside and you want to cool your building, it's not 40 degrees in the ground. So your heat pump is also working efficiently. And the heat you take away from your building, you're not throwing it into the environment, you're storing it in the ground, where in winter you can extract it again with your ground source heat pump, which is again more efficient than your air source heat pump. So it's a cycle. It's a vicious cycle, but this time it's a positive vicious cycle. Another thing is related to the lifetime and the maintenance. An air source heat pump typically has a lifetime of 50 to 20 years, and a ground source heat pump, it's typically longer. And the bore field is even 50 and longer than 50 years. And the reason is actually simple. An air source heat pump, it stands outside. It has an outside unit and it faces weather conditions, wind, snow, rain, stones, perhaps depending on where you live. It's more prone to leaks due to that. Remember, if the defrosting cycle, if there goes something wrong with it and the heat exchanger, there are some cracks in it, it's more prone to leaks, these air source heat pumps. Which also means that their maintenance on average is a little bit higher. But also if you have, for example, aggressive environments, you're at the seaside, the air, it contains some of the salt. And this salt, it reacts, not so much reacts, but it damages the heat exchanger in the air source heat pump. So also there, the lifetime is sometimes even lower than this 15 years. So that's also something to take into account. Perhaps the investment cost of the ground source heat pump is higher, but if the lifetime is also way longer, it will pay back. And then you also have the aesthetics and the noise. So ground source heat pumps, as you know, they don't have an outside unit. It's just one unit inside your building, and there is also no noise from the ventilation. And nowadays, air source heat pumps are also very quiet, but if you have hundreds of them, 100 times very quiet, still can be heard. And this is not the case with ground source heat pumps. So they are typically seen as being more premium, let's say. It's the better quality. Now, these were the individual reasons. Now, there are also some collective reasons, which is more important if you're a government or a policymaker to take into account. And one is the urban heat island effect. Now, the urban heat island effect is basically stating that in city centers, the temperature is higher than on the mainland, on the rural land. And that's because there is quite a lot of concrete, quite a lot of road pavings, and these all captures warmth and it heats up the city more and more and more. Even to the case that it's 5 to 10 times higher on average in a city than it is on a suburban residential area. And if you see walls like this in cities, where each apartment, each building has its same air source heat pump, we're just dumping all of that heat into the city. So the city center heats up more and more and more. And that's why some people say that in cities, if you go for an air source heat pump, it's actually a very egocentric choice. Because by doing it, one, you heat up the whole neighborhood. And if the neighborhood is warmer, the heat infiltration into your apartment or your building will also be high. So your heat pump should work harder to keep your building cool, and it's a negative vicious cycle there. So for urban heat island effect, especially take into account the climate crisis and the increase of global temperatures, it's important to take into account. And the last thing, also take into account the climate crisis, is that we want to go to more electrification, but our net of distribution or transmission lines should be able to handle that. And I've shown here a picture of the Netherlands, where they experience quite a lot of problems with net congestion. So net congestion basically means that there is no capacity available for new connections. So you cannot connect new buildings, new industry to the electricity grid because it's full. And all the red dots on this map is where there is no capacity available. And the orange is where it's not available at the moment. So most of Netherlands is just incapable of connecting new houses, etc., to the electricity grid. And this is due to the fact that intermittent PV and wind capacity, it congests the electricity grid. We have electric vehicles that are coming onto the market, and we have heat pumps. And here, the net congestion, it takes place at critical moments. And when is that? When there is quite a lot of demand. And when there is quite a lot of demand, your ground source heat pump is more efficient than your air source heat pump, so it requires less electricity, so there's less congestion. So this whole situation here can be not fully mitigated, but at least it would not be as worse when it would have been with all ground source heat pumps instead of all air source heat pumps. So from a policy point of view, it's important to take into account when new neighborhoods are being built, that ground source heat pump neighborhoods versus air source heat pump neighborhoods would require less power and less, it would put less constraint onto the electricity grid. So these are quite a lot of reasons why a ground source heat pump is actually perhaps a better solution than an air source heat pump for your project. Now, of course, everything we talked about, the long lifetime and the high efficiency and the low operating costs, it's all contingent on the fact that your ground source heat pump should be designed correctly, but also your bore field should be designed correctly, because you can have a very good ground source heat pump. If the source, the heat source, is not well designed, it's too small, then it can be that your system is not functioning rather well. And that's actually a shame if you invest sometimes more into this ground source heat pump, that it's not functioning at its best. And that's why it's really important to use design tools like GHG Tool, why you should subscribe to this channel, you should read up on our articles on our knowledge base. And also, if you think this was interesting, share it with your colleagues, share it with someone who needs to know about ground source heat pumps, and I'm looking forward to seeing you in the next video. Take care.